Hello, chemistry students. Welcome to day 4 of Gibbs free energy, the exciting part, spontaneous reactions. Spontaneous reactions are reactions that are energetically favorable and they occur without outside energy. Systems in general move from high energy state to a low energy state. And in general, exothermic reactions are spontaneous, but not always, because we have that Gibbs free energy. Here's some examples of some spontaneous reactions. Bursting of a hydrogen balloon. The decomposition of hydrogen peroxide with a catalyst. This is elephant's toothpaste that we did at Halloween as a demonstration. And iron nail oxidizing with oxygen are all examples. I wanted to talk about this spontaneous reaction and how important it is to know what reactions are spontaneous or not. And I have a picture I'm going to pull up real quick that I found just the other day at my part-time job at the hardware store. This is a warning label that is on the top of a stain can. And notice it says to avoid spontaneous combustion, soak soiled rags and waste immediately after use in a water-filled closed metal container. So you're wiping, it's a wiping stain, and this stain is flammable and could cause spontaneous combustion under the right temperature and conditions. So it's very important that we know about these things and that we are cautious. Another spontaneous reaction that I see example of is when tear gas is used, especially in a closed area. There have been many tragedies where tear gas was used in a situation and a fire broke out or spontaneous combustion occurred. So knowing that tear gas can undergo spontaneous combustion, it is very dangerous to use tear gas in an enclosed environment for any reason. Okay, let's go back to when we were talking about the evaporation of that beaker that I left in the classroom over break. We know that it will evaporate. And in order for the water molecules, even though it's an endothermic reaction, we know that it will spontaneously evaporate. And it is because the entropy increases, the disorder increases between liquid water and gaseous water. So if a system goes from a high energy state to a lower energy state, there must be another factor, and that second factor is entropy or randomization. So how can reactions be spontaneous or exergonic? Changes in free energy, again, are quantified by that equation. The Gibbs free energy is equal to the enthalpy minus the temperature times the entropy. And so if enthalpy decreases and entropy increases, enthalpy can increase, but entropy can decrease, and it weighs it out. At higher temperatures, these are more likely to happen. Enthalpy decreases enough to outweigh a slight increase in entropy. And these are all situations that can occur. And there will be a worksheet that I'll put up later that will allow you to relate these things and see how the difference between entropy and enthalpy can affect free energy and spontaneity. An exergonic reaction, remember, is one that releases free energy to its surroundings. And an endergonic reaction is one that absorbs free energy from its surroundings. So let's take a look at this graph of free energy and how it works. Notice that the energy output in this first case, in the first example, the initial state has more energy. The initial state here has more energy than the final state. so that the free energy change is a negative value. And it's exergonic, or it releases energy. It's exergonic. The difference in free energy of the products and the reactants represents the amount of free energy that is released. In the second example, the initial state has less energy than the final state. And so in this case, we have a positive delta G, and the amount that it's positive is the difference between the reactants and products. You will work out some of these equations in the Gibbs free energy worksheet number 3 that I've put on your homework. Both reactions are spontaneous and free energy decreases. Okay, so I want you to look back at the videos of the dissolving calcium chloride versus the ammonium chloride in my playlist to help you with this and how this works. So again, we note that this is the equation. This is exergonic and exothermic. And the other one, however, the ammonium chloride dissolving, is exergonic but endothermic. The change in entropy, the disorder, is greater than the change in enthalpy, and this is how this can happen spontaneously, even though it's an endothermic reaction. So here are some examples in the real world of decreasing amounts of free energy. There's 3 examples here. The girl moving down the slide is moving from an area of less stability to an area of more stability. There's a decrease in free energy. In the case of diffusion, when the molecules are on one side of the membrane, they are more organized. In the second picture, there's an increase in entropy as the molecules move from one side of the membrane to the other side of the membrane. Finally, the last example, the molecule is decomposed. The products have less energy than the reactants. All of these would be a decreasing amount of free energy.